All right, everybody. So I'll be making two videos today. Um, my next one, which I haven't made yet, is going to be on how you conduct a hypothesis test. Um, but as I was making the slides for that one, I thought it's hard to see what you're accomplishing when you go through the procedure. So I wanted to make a video to explain what's happening the best I can when you conduct a hypothesis test. And then when you're working the problems in the assignment or when you're watching the next video, you can think as you're going through the steps that what I show you in this video is what's happening behind the scenes, okay? So I'll call this one the concepts and the math of hypothesis testing. So just to start, let's think of this situation right here. So say we take a random sample, and remember, when we take a sample, it's got to be random. You can't pick and choose what you want, all right? So we take a random sample of 89 eighth grade students, scores on a national mathematics assessment test, um, and there's a mean score of 273. Okay. But suppose that the mean score for the state's eighth graders, so we might think that's the whole population on the exam, is 270. So the sample came from the population. The mean for the population is 270, and the mean for the sample is 273. Okay. Um, and then from there, it says the population standard deviation is 35. All right, and I'm curious, like, what's the probability that this sample, remember X bar is the sample mean, what's the probability that if you had a sample of 89 scores, that you'd get a mean score in that sample of 273 or more, okay? So to do that, to find that probability, I have to remember something from test 3, that the sample mean has a normal distribution under certain conditions, and this is one of those conditions. So the sample mean has a normal distribution with a mean equal to the population mean, okay, which is 270, and a standard deviation equal to the population standard deviation, which is sigma, this thing right here, over the square root of the sample size, which in this case is 89. So the X bar, the sample mean, has a normal distribution with a mean of 270 and a standard deviation of about 3.71. Okay, so I then went to StatCrunch, okay, and I put in, to do a calculation, what's the probability that we have a number that's 273 or greater, okay? And so did all that in StatCrunch, and I got about 0.209, which if we express as a percentage is about a 20% chance, 20.9%. It's like a 1 out of 5 chance. So, all right, it's not like it's super unlikely that we would get that number from a random sample, okay? We got a 20% chance of getting it. It's not real likely either, but it's not like it's really, really unlikely, okay? It's entirely within the realm of reasonable possibility that we got that number. So I'm trying to say that there's nothing suspicious about any of this. The fact that the population mean is 270 and that we had a sample of 89 and that the mean there among that sample was 273. Nothing strange about that. None of the numbers were exceedingly unlikely. Okay, now let's take a step further. Suppose we took another random sample, and I emphasize random, okay? It's like we did not pick and choose just the students with high scores or something like that. Random means like anybody has an equal chance of being chosen to be in the sample. Okay, so another random sample, 89 students' scores, had a mean score of 287, okay? And the population mean is still 270 with the standard deviation of 35. So here, like, what are the odds of getting a number in this range? Like, say, not just 287, but 287 or greater, okay? Well, again, that comes from the same normal distribution. The sample mean, okay, from a sample of 89 has a mean of 270, which is the population mean, and a standard deviation of the population standard deviation over the square root of the sample size. So that's the same distribution, and I went to StatCrunch again. I did the same thing, but I calculated the probability of my number being bigger than 287, okay? So, and here's the number it gave me this time. That's supposed to be an X bar right there. It gave me 0.000025, okay? And whoops, I wrote down, I'm sorry. Okay. 25, okay. So that is a very small number, okay? If you convert that to a percentage, that's 0.00025%, far less than a 1% chance. All right, so I mean far less than 1 out of 1,000, okay? It's exceedingly unlikely. So I'd say, well, something's not right. Like, and I wouldn't know, I have no way to know what it is if this was just the information that I was given. But the fact that you got a sample with a mean score of 287, that high, where the probability that it is that high or higher than that is this small, practically zero chance number, something's not right. I don't know if the miscalculation on the sample, or in hypothesis testing, we questioned the claim that was made about the population mean. Okay, that's one of the things we do in hypothesis testing. So we'd say in this case, yeah, I mean, it's probably, if the sample means that high, and it's this unlikely that we got that number, it's probably that the population mean is reported incorrectly. Okay. All right. Now, so that's what's going on when we do hypothesis testing. When I show you the procedure, you'll see that we calculate probabilities, and it's kind of going to be buried in a lot of steps, and so it won't be real obvious what you're calculating the probability of if you just go through all the steps. But you're calculating the probability basically of your sample mean being what it is, given that the population mean is reported what it is, okay? And if that probability is small enough, then we start to question the claim made about the population mean. That sums up the math behind hypothesis testing, okay? Now, here we didn't look at the procedure anywhere. Calculating this probability is something that we could have done when we learned what we learned for test 3. Okay, but nonetheless, this represents what's going on behind the scenes of what I show you in the next video.